Okay, hi guys. So we'll be continuing on seeing more questions on the concepts we discussed in the previous lecture. Okay, so the first question is how many milliliter of water should be added to 200 ml of 0.6 m HCl aqueous solution to dilute the solution into 0.2 m. What should be the final volume and how much water should be added? Okay. So again, number of moles of HCl will remain the same. Number of moles of HCl would be molarity of the solution into volume of solution, which would be equal to molarity of the solution and the volume of the final solution. So molarity here is 0.6, volume should be 0.2. Similarly, molarity here is 0.2, volume is to be calculated. So volume is 600 ml. Okay, now obviously you have poured water into it, and so the water added would be 600 minus 200, which is 400 ml. Okay, next let us see another question on the same. So suppose we have, or the question is, what volume of 24.5% by weight H2SO4, which is with a density 1.2 gram per ml, is required to prepare 1 liter of 1.5 m H2SO4. Okay, so 25% by weight H2SO4 is there, so we can write it like 24.5 gram H2SO4 is present in 100 gram water. Okay, and when we say 1 liter of 1 m solution, so final moles would be final molarity into volume final. So final moles can be calculated with n equals to final molarity is 1.5 and the volume is 1. Hence final molarity, final number of moles is 1.5. Okay. Now with this we calculated the final number of moles as 1.5. Now this moles should be also available in the initial sample also. So in the initial sample we must have final number of moles equals to molarity initial into volume initial. Okay, one way of looking at this is this. Another would be, you can say that this is the density of the solution, not the H2SO4. Okay, so when we talk about volume of solution is, again, we have mass of solution. This is not 100 gram water, this is a 100 gram solution. Okay, water would be 100 minus 24.5 grams. Okay, volume of solution would be 100 gram, which is the mass of solution, divided by 1.2 ml is the volume of solution. Okay, now or rather let's start off with this, that let's say we cannot assume volume of solution directly, right? We have to calculate the volume initial also. So let's suppose we have x gram of solution. Just cancel this approach, or just let me write it here. 1.5 is equals to, let's say we have x grams of H2SO4 solution. So given mass of H2SO4 would be 24.5% of x divided by the divided by the just molar mass of H2SO4, which is 98. Okay, so from here x can be calculated. X was the volume of solution. Okay, so let me erase this up here. We don't need that could be one of the approaches to solve, but a simpler approach is directly going by the approach that number of moles of H2SO4 is equals to weight of H2SO4 divided by molar mass of H2SO4. Okay, mass is 1.5 equals to, let x be the weight of solution's mass rather, you can call it mass, weight, whatever. From here x can be calculated as 1.5 into 98 upon 0.25245. So x was the mass of solution. Now the volume of solution would be 1.5 into 98 upon 0.245 divided by 1.2. This ml would be the volume of solution. Okay, let's take on another question where we have that 200 ml of 1m HCl solution is mixed with 800 ml of 2m HCl solution. We have to find the molarity of final solution. So initially we have 1m solution, so molarity is 1, volume is 0.2, number of moles of HCl would be m into v, which should be 0.2. Now it is mixed with 800 ml of more HCl. Okay, so NHCl, this would be 1 then, and NHCl2 would be 0.8 into 2, which would be 1.6. Find the molarity of the resultant solution. So when these two are mixed, final moles would be, rather N final would be number of moles would be just added. Okay, so number of moles would be 1.6 plus 0.2 which would be 1.8 divided by total molarity of the total volume of the solution would be 1 liter, 800 which is 0.2 plus 0.8 which is 1 liter, so final molarity is 1.8. Okay, let's see another question. So here let's say we have HCl, okay, which is present in m molar 1 v1. One HCl is present in m1 v1, another HCl is present at molarity of m2 at volume v2, and another HCl is present at m3 v3. So what is the molarity of the solution? Molarity of the solution would be number of moles m1 v1 of the three HCl solutions over volume v1 plus v2 plus v3. Okay, so this is the number of moles and this is total volume. Okay, now let's see actually one more interesting problem. Okay, so suppose we have 50 ml of 50% W by W HCl solution, HCl aqueous solution, okay, and which is mixed with another 100 ml of 70% W by V HCl aqueous solution, and the same amount of water is added in the final solution in order to obtain 1.25 gram per ml. Okay, and same amount of water is added in the final solution to obtain 1.25 gram per ml, which would obviously be the density. Okay, dense solution. Okay, so which is having 28% W by W HCl solution. So how much mass of water is added, that is we want to know. How much mass of water is or was added. Okay, so you can pause the video and just solve this question and then come back to have the solution, have a look at the solution. So let's approach the problem. So initial weight of HCl is 50 into 1.4. okay, and this would give out the mass of the solution. Okay, I forgot to write the density of this solution. Density of this HCl solution is 1.4 gram per ml. Okay, now initial weight of HCl solution would be 50 milliliter is already given, and density is 1.4, so you can calculate the mass. Okay, and initial mass of initial weight of HCl solute would be 50 into 1.4 into 0.5, as it is 50% W by W aqueous solution is now mixed with another 100 ml of W by V HCl solution. Okay, so what would be the weight of the HCl solution here? Weight would be 70 grams, simple. Okay, because in W by V we take V in milliliters. Okay, so 100 ml of when you take this actually implies 70% gram in 100 ml solution, and we have already been given that it is 100 ml solution only, so mass would be 70 ml only, 70 gram only rather. So this is the initial weight of HCl solute. Okay, so total volume of solution would be 50 plus 100 plus V is the water added. Okay, now the final solution, we have that the final mass of solution is, or rather final mass of solution would be 150 plus V multiplied by 1.25 G by ml, because this is the density and this is the volume. Mass would be this. So how much mass of water is added? So finally we have also been given that it is 28% W by W. Okay, so we can say that initial mass of HCl would be equal to final mass of HCl. Okay, this implies initial mass of HCl was this one, let's call it number 1. So number 1 value we already know, it is known value, you can calculate it, and which is equal to mass of HCl. Mass of HCl finally would be, so here mass of HCl finally would be that this is the total mass of the solution, and finally we have 28% W by W. So mass of the solution is this, so the mass of HCl would be 28% of this, so 0.28% of second thing. Second thing is a variable from which V can be calculated. Once V is calculated, we know the weight of volume of water added, which would be equal to weight of water added, as density of water is 1. Hence you can calculate it, and volume would come out to be 150 ml. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples. Rather we'll be seeing mixing of liquid solutions, and then seeing some more examples on the liquid solutions as well as molarity and molality concepts. Okay, till then, good luck and goodbye.